Water is so much. Water is so much better with top hat ice cubes.
And if you need a glass of wine, there's a glass of wine here for you.
Okay.
There's also cake and ice cream downstairs.
I saw that. I'll take a look at that and we'll.
This is, yeah, wow.
Remember,
No question.
what time is it?
It's 7:30.
That's it. This one goes also on-
3 people entered the waiting room.
I don't think we will, right? Like, the more games.
It's my desk, that's what I use it for.
Yeah. So you got the phones and the page layouts.
You got the game in the front and then everybody talking about me lying on that.
No, zoom on around.
Yeah.
And then put a flute and all that. I got you. I feel like, hang on.
Good.
Dennis said the same thing. It's not that.
Oh,
I don't care, because I only, like, the fact that I have email and an Excel spreadsheet open, I kind of know it's easier. No, I don't like it that people can come into the room and I don't know that they're there. So I like to be able to like see the staircase and see the driveways of into the room. And I like the screens are whatever. You can the light behind me and the air is very much
perfect.
Maybe that's good though. It's not.
I used to have one that was like, I worked here. And then this was against the,
Okay, you're gonna sit down for a moment.
which worked okay, except then you're staring at the
Is
person,
there anything
you're sharing the office.
you want me to pay attention to specifically as I can talk?
We try something new every few months.
I don't know, you could have gotten on, here's the Zoom of the talk
Oh,
going on.
Ted, do you want that third camera to be active?
I can
Steve's
also-
asking for the third
I
camera.
think I might be able to.
I'm
The
asking
camera with
whether
Evan,
you-
I don't want to be
So
camera.
I said it was,
Can you make sure that this camera's turned off?
I can
It's happening
simply,
increasingly with my.
I can simply view that on YouTube
Okay,
too.
now we're gonna be quiet on set for a moment.
One of them is named Zooey. Sounds too much like Siri. So many of the things that have popped with me very sharply saying his name have been transcribed as a text message.
Nikki,
Yes.
you're admitting people?
Yes.
Don't tell mommy, you just.
Yeah, we can watch another movie, just.
Turning this on.
Nice.
Evan, no, turn that off.
No audio, Ted.
Can you hear me now?
Yes.
Okay, something went wrong with that microphone. We'll try the other one. Because it's a backup. We have a backup. I don't understand why, but the blue light, yeah, this is the first time I've used this one, so we'll see if it works. But it might be time. Okay, can you hear this?
Yep,
All right, that's working.
yep.
2A, 1B, this one's off. Okay, let's take yours off. Let's change it. For this one,
The current,
There.
current display on the YouTube, screen is the abstract with the picture.
okay. All right, well, good evening, everyone. We are at Bay Chi, where we are at Other Lab, and you can see this 120-year-old or something door behind me. We're in a fully functioning invention lab that Saul Griffith and Jim McBride founded. And we are not only here, but if you look around, you'll see that there's pipe organ pipes on the wall. And these pipe organ pipes are part of the legacy of this being a functioning pipe organ factory until maybe five years ago. Maybe it's 10 now. In any case, welcome to the program tonight. And tonight we're going to talk about disability, assistive technology, and computer interaction. But before we get started, I will just take a moment to share with you that we are a part of a 75,000 person organization called Association for Computing Machinery, and SIGCHI, which is the second largest part of ACM, has its annual meeting in May in Hawaii this year. Please go. You can also go virtually online. But we are Bay Chi. Bay Chi is part of that, and we are for the Bay Area. We have a program every month. We have other things that we do, and we really welcome people to join. The most important thing, of course, is the monthly meetings, but we have steering meetings, which is anybody that's interested in being part of Bay Chi can come to these meetings, tell us a little bit about what they're doing, but help us also think about what Bay Chi is and how we do it. I don't know why. Okay, somebody else should be admitting these people a little bit. We like people. Oh, it is not. How do I get these slides up there? I'm not giving the slides over to there. Share. I am sharing. I guess people do see these online. They just don't see them over here. How do I put them over here? How do I mirror? Well, I'll just talk to you guys in this room, but the rest of the world sees that we're talking about a publicity team that has Con Nguyen, and we have Alexander Delory helping. We have Nikki Philman, our very own, who helps in-person coordination. This evening it had a lot to do with ice cream and pizza, and also some other nice things for dinner. Thank you very much. The newsletter, we have Marianne Ray and Steve Williams putting that out monthly, and we are starting to do a better job of getting it out a little earlier. I hope you guys came because you found us on in your newsletter, or found us on Facebook or Twitter, or I don't know, it isn't called Twitter anymore, various LinkedIn. There's a Birds of a Feather meeting that Edwin Lee runs on the fourth week, Tuesday. You can even show with the video. And it is for people that are interested in talking about their careers and what they're trying to do in HCI. But there's also a working group every week, and that is what night? Wednesday afternoon. What time?
3:30 to 5:30.
That also Edwin runs, and this is a vital thing for people that are looking for work or want somebody to look at their work. That it's kind of, it's kind of just a working group, just a bunch of us kids. And then I'm in charge of programs, and we have various things on the roster. It's not clear what next month's will be. It might be a visit to a VR company where they use glass beads for reflection, and it's a very unusual approach to VR. That's at Switch 5 is the name of the company. Wonderful CEO, Jerry Ellsworth, fantastic speaker. And then in June, we will have Victoria Bellotti, who's a famous, well-published anthropologist that thinks about HCI and was at Park till recently. We have a new treasurer, and that's Melissa Guire. And she's more than a treasurer. She's diving in and getting interested in lots of different things about Beikai. So that's kind of what's going on. Please consider joining in. We have many, many other things that we can do. For example, tonight we have Eben Selker, who has been doing the editing of all the videos. And I would love if somebody worked with him to review them, because being related, I shouldn't be reviewing his videos. But also we should be announcing. For example, last month, we had Larry Maggett, very famous writer. He's been writing about technology for 45 years. Radio shows on CBS for 25 of those years. Amazing, amazing speaker, I thought. And the video just went up on YouTube. So that's something that you guys should look forward to doing, going to the Beikai video. Now, David Jaffe, I've known since, yes? Okay. David Jaffe, I've known for I don't know, 40 years, I think. I met him in 1980. He worked at the VA Rehab R&D Lab.
Worked.
What?
Worked.
I got it.
Okay.
Okay. And the lab survived for a long time. Now it's part of a lot of development that goes on over there. But what he worked on was many disabilities things. You'll see some of them with him in a wheelchair, using just a head to control the wheelchair long ago. And it's very interesting that you can use your head to have gestures with other people and still control, decouple what you do to work with a wheelchair. So very innovative guy. Now he's been teaching for decades now at Stanford. And as in that role, he puts on a disabilities class that has projects. You'll hear lots more about all of these things during his talk. And without any further ado, I'm going to try to switch over to his slides and introduce him so he can give his talk. And I think you know what to do from here. So David, please come to the podium.
Okay. All right. Here I am.
Oh, and one last thing is Edwin wanted me to mention that in June we have elections for treasurer, vice president, vice chair, chair, and chair. And we're open to losing our jobs. Please take our jobs away from us. So anybody that's interested, think about taking on more responsibility in Beikai. We're happy with.
Mm-hmm. Okay. Thanks, Ted. I want to thank Ted Selker for inviting me, because I think this is the closest I'll get to a real TED Talk. Yeah, this is me. And next slide. How come? What?
Just use the arrow keys.
Oh, these down here?
No, these are the arrow keys.
No, it didn't work.
Look over there. Let's see. Okay.
Ed, on Zoom, we still see your slides.
Here, I guess that's working now. Okay.
So are you seeing my slides now?
Yeah, see, you're seeing.
Yes, we are. Thank you.
You're, okay.
Okay.
Do you see David Jaffe's slides, right?
Yes, we do.
All right. Okay. We're set. What?
We're seeing the big stuff. Oh.
Okay, how do we change that?
There it is. How about now?
Look how you're in Zoom.
Oh, at this point, now we're just, we seem to be cycling through various video streams. Now it's both pictures of the live video, which I don't think we'd want.
Just
There we go.
Okay. Forgive me. I think we are at
I use those arrow keys.
just a moment. Okay, now you can use these.
Okay, great. Okay. I'm always so glad when the technology works. So let's get going here. A little bit more about me. I went to University of Michigan undergrad in electrical engineering, and then I went to Northwestern for graduate school in biomedical engineering. And I worked at the a VA hospital outside Chicago for a number of years before coming out to California, working at the VA hospital there. We had a center called the Rehabilitation Research and Development Center, where we worked on projects to benefit veterans with disabilities, including those with spinal cord injury, which is the clinic right across the street. And in 2007, I moved over to Stanford and started teaching my course. I've been not only teaching the course, but helping out in other courses, and also trying to connect with other people, other students who are doing assistive technology projects outside of my class. And it's just interesting to see what I look like when I was 22, when I was at Northwestern. And the students really get a kick out of that. And I tell them, you know, wait till you're my age, you know. Right. And so the center that you see there is now like half torn down, which is really distressing. But there's nobody working in that center anymore. So my background, I remember growing up and being inspired by Watch Mr. Wizard. How many people remember that? All right, just the old people. Thanks. And on the bottom left was my computer in 1978. I had an original Altair computer. How many people remember that? Okay. And so I remember a meeting we had in Chicago of all the people in the Chicago area who had a home computer. And the 10 of us sat around one table, and one of those were me. And let's move on. So I'm going to be talking about, you know, 5 topic areas about disability and assistive technology, design process that the students use in my course, and course description, some of their student projects, and some devices and products that are, you know, human computer interface type projects related to disability. So what is disability? So, you know, there's a lot of definitions depending on who's doing the defining and what kind of numbers they want. But, you know, my definition is started as an opportunity-based definition that defined as any health condition or impairment that prevents an individual from taking full advantage of life's opportunities, such as education, vocation, recreation, and activities of daily living. But you know, I updated my definition of disability to not just a health condition, but any condition that prevents any individual from taking full advantage of one's talents and life's opportunities, including circumstances such as the political environment and socioeconomic status. You know, for example, if you're on a planet that's under attack by the empire, right? You know, your talent as a, you know, a classical pianist, you know, may not come into play. But, you know, in closer to reality, in Iran, you know, girls don't go to school after 6th grade. You know, they're barred from school. So just being a female gets you out of school. So does being a female, is that a disability there? I would say so. But a more inclusive definition of disability comes from my colleague Gregor up in Canada, and he says that disability is a normal variation of the human condition. Well, why should that be the case? Well, there's so many people with a disability, and you'll see that coming up, that you know, you can't, they're not a minority anymore. So this idea of this binary difference between able-bodied and disabled, is doesn't exist. So there is nothing, akin to normal versus abnormal. And now we talk about a lot about biodiversity, neurodiversity, the spectrum of autism, and also, maybe there's a thing called ability diversity that goes along with this as well. And as the rock group All right. All right. I hope you can hear me. All right. Well, now I can't. Okay. All right. So here, here's a map of the U.S. And according to this data, there's 61 million adults in the U.S. with a disability, which is like 26%. So that's 1 in 4. So that's hardly a minority. There's some, people with some kind of disability. And this is a slide that I use in class. So depending on how you count, there's millions of people in the U.S. with activity limitations, and which is, according to this, 23%. And that varies depending on who's making the survey. There are millions of people with severe disabilities. Children have disabilities. Healthcare costs related to disability is pretty high. Disability is the largest minority group. There's a lot of people that are over 65, including myself, that might have a disability. There's people with vision impairments, hearing impairments. There are wheelchair users and people with developmental disabilities, but less than 5% of people are born with a disability. So it's acquired after birth. And when I have this slide at Stanford, I note that 12% of the Stanford students are registered with the Office of Accessible Education with some kind of disability, and that could include ADHD and other things. So it's a big numbers all over. Disability rates vary by age, gender, race, ethnicity, state of residence, and economic status. So a person with a disability may have reduced chance for education and employment. And that's really critical, because if you don't have an education, you can't get a job and can't make money. And so you're living in poverty, and that's not good at all. And as people age, the number of people experiencing limitations will increase. Okay. So people with disability, of course, want to be well and be fully functional. They want to do things on their own, be independent, have a high quality of life, and take full advantage of all of life's opportunities, and of course pursue happiness, and have the freedom to integrate, fully into society or be a part of their own little group. It's up to them. They have the freedom to do that. So I bring up this slide, and everybody remember Matrix? Remember this scene where they said, can you fly a B-212 helicopter? And what did they do? They stuck a probe back in the guy's head, and within seconds, that information, that skill was transferred to that individual. If we can only do that now, maybe we'd be better off. But there's actually people working on this kind of stuff. In society, there's a lot of people with disabilities, and they may be fictitious people. So my first person with a disability was Captain Hook and Pinocchio. And of course, you have Quasimodo from the movies. He went to Notre Dame, which is in South Bend, Indiana, right? And I guess being a pirate, is pretty dangerous, because this guy has a hook and a peg leg and an eye patch. So that's tough. And Joseph Merrick, what was his name?
Yeah.
The Elephant Man, right? And what was his condition?
Remember the name of it?
It's elephantitis. Right. And then we have the munchkins, and beyond people, there's animals with a disability, and there's actually been 2 films on this dolphin that they made a prosthetic tail for, two movies. And of course we got from Harry Potter, King's Speech is a real movie about a person who stuttered. And then we have Dr. Strangelove, obviously, one of my favorite characters, in a very old wheelchair. So it sort of permeates society. Here's some more people, and every year I add more to this list. So we got Moses here, we got Helen Keller, we got Jay Leno, we have Hitler, we have Stephen Hawking, and of course, the Daleks, from Doctor Who. You recall, this is an alien who needs protection. He can't, walk outside. So they created an exoskeleton, for him, and an exoskeleton is assistive technology. Okay, so
For them, they're a whole people.
yeah, and some new inductees includes King Tut, who they did a scan of him, and they found that he had deformity of his left foot, and in his tomb they found all sorts of canes, and there's even carvings of him, and here's a recreation of him. So disability goes way back. And of course, even superheroes have a disability, as Superman, and exposed to kryptonite. So we're superior than Superman in that respect, in that we can be exposed to kryptonite and not have any ill effects, right? So let's talk a little bit about assistive technology. And of course, the definition is the first thing. So people usually think of assistive technology as a device-oriented definition, where it's as any piece of equipment or product, whether acquired or commercially available, or modified or customized, that can be used to increase, maintain, or improve the functional capabilities of individuals with disabilities. But my definition is obviously broader, which includes not only devices, but services and policies that benefit people with disabilities, and institutions and facilities, where that work takes place, and the process that makes it happen. So an assistive technology device is one that has a benefit, which could be a diagnostic benefit, a functional benefit, or a rehab benefit. And an AT service provides various resources to people with disabilities. And of course, AT policies, laws, and legislation, are things that mandate the provision of these devices and services. Okay, and engineers employ an assistive technology process to specify, design, develop, test, and bring to market these new devices. So, assistive technology devices then improve the quality of life and independence of people with disabilities by enabling them to perform tasks that they were formerly unable to accomplish, or had a great deal of difficulty accomplishing, or required assistance through an enhanced alternate method of interacting with the world around them. That's pretty straightforward. But I realize that the devices that we use improve our quality of life by the same reasonings, by enabling us to perform tasks that we were formerly unable to accomplish, or had difficulty accomplishing, or required assistance through an enhanced or alternate means of interacting with the world around us. So a couple more things before I get to the point here. So there is new devices being developed all the time that further improve the lives of people with disabilities. And there are new devices incorporating novel designs that improve the life of everybody. So this leads me to conclude that everything is assistive technology, okay? Because, I mean, we're like cavemen, without all this stuff, we're pretty disabled, right? And so I mentioned, computers and cars and airplanes and phones and electricity, hospitals and roads and stuff. And I asked my students, what's the most awesome piece of assistive technology? And the answer is Stanford University. Now, when I'm talking at Berkeley, you know, I substitute, you know, their logo in there because I don't want to get into too much trouble. Okay. Does everybody buy that? Okay. I mean, it's just a different way of thinking. So in summary, there's lots of people in the US and worldwide, over 1 billion, you know, with a disability. And wheelchair users, you might think there being several million might be a homogeneous group of people because they all use wheelchairs. But it's not, because every wheelchair user that I've seen, you know, has different requirements, needs for their mobility, and different preferences, goals in life, and aesthetic preferences, and different challenges. So what I'm trying to say here is that even though there's lots of people with disabilities, and you might think that's a huge market to address, it's actually fragmented down to the individual. And this was what makes provision of you know, products, assistive technology products expensive, and the companies that produce them are small. So that's this thing here. So, you know, because everybody is a little bit different, everybody is an individual, whether they're disabled or not. But so that's the point there, is that it's hard to address this market because everybody has a little bit different disability. So how would you do that? So I created this concept called individual design. So because individuals with disability have their own personal challenge that may only be addressed by a custom solution. So some of that examples of that are, you know, fitting the wheelchair seating, prosthetics, lap trays, and devices to aid people with in activities of daily living. And of course, a big thing that people have is the sense of coolness of something. Everybody, there's so many decisions that people make unknowingly that, you know, for our clothes and stuff, that said, you know, will this look cool, you know, for me? Do I like this color on my car? Do I like this car because it looks cool and stuff like that? Everybody makes these decisions every day. So the coolness factor is actually a pretty important thing, not only in assistive technology, but in everyday life. So a little bit about the course so I've been teaching this course for 18 years. It's called Perspectives in Assistive Technology. And so the objectives for the students is for them to gain additional engineering confidence, applying the knowledge and skills that they have for other courses in addressing problems that people with disabilities experience. So I try to focus on having the students do critical thinking and enhancing their communication skills, working as a team, interacting with individuals in the local community. And these are things that that everybody needs to do. These communication skills and working in a team and solving problems are things that everybody does on their job, right? So I try to give them these kinds of skills in this class. They certainly learn about the design, development, and use of technology that benefits people with disabilities and older adults, and they practice, you know, some leadership skills in their team. So you know, they're given a problem, they have to analyze it, they have to do problem solving, they have to work in a team, they're working in the community, which is called public service, and it's also called service learning. And they go through a design process, which includes designing, fabricating, testing, analyzing, and iterating until they meet all the design goals. And they enhance their communication through reports, presentations, and class participation, because nobody told me as an engineer when I went to school that communication skills were important. All right? Did any of your instructors tell you that when you went to school? So, I mean, what did you think? That you as an engineer, you know, wouldn't have to do things like write reports or doing presentations or talking at Bake High, they didn't know, right? So, I mean, it's really important. So, I mean, I focus on that in my class. And of course, having leadership skills on a team and organizing their project is really important. So, so my course is a little bit different. There's no studying involved. There's no quizzes, no problem sets, no exams, and finals. So the students get graded on their reports, their presentations, and their project. So there's no textbook. So remember when you were in school, you bought a textbook and say, today we're going to do chapter 3, and on the back of the chapter, you're going to do these problems, for next class. You remember that? So none of that doesn't make any sense. So I bring in guest lecturers so students don't hear my voice the whole time because other people have better things to say. And I want to get students excited about learning something that may have a more practical application than some of the courses that you took. I mean, think about all the courses that you took that you've never used anything from that. That's a lot of stuff, right? Never used, okay? Students don't need to learn how to study better and take exams. I mean, that's not something you do in a career, right? Okay. And of course, I tell the students not to take notes, just to be attentive. So the course is about technology and people, assistive technology in many forms, and going through this design development process. I'll talk about working on a project, engaging with real people with real challenges. And I see that as a prelude to their professional life. Okay, so the course structure, it meets twice a week, and I bring in guest lecturers to talk about various things. I'll talk about that a little bit later. There's opportunities for thought, reflection, and discussion, and there's a project experience, which includes identifying a challenge, understanding it, brainstorming solutions, designing prototypes, testing them, reporting, and things that benefit a real person. I mean, how many courses did you take that involve real people from the community? Anybody have any courses like that? Okay, so the students really like the course because of this, because it makes sense. They're doing something that's of obvious benefit to a real person, and that makes it all real world rather than imaginary in my mind. So I talked about the project experience that includes working with a person in the community and prototyping solutions and testing it with them to make sure that it works, and going through an iterative cycle till they get to the end of the course. And we have midterm and end-of-term reports and presentations. And at the very end, we have project demonstrations that I'll show you some pictures from. So the students have an opportunity to employ the skills that they already have. And some of the students in the class may not be engineers, but that's okay, because there's lots of support for them in building stuff. So projects are not just about building things, it's building people, building character. And you can sometimes attack a challenge by starting with the challenge, or maybe starting with the technology. If you have a new technology, you can say, hey, this might really work, solving this other problem. And that was the situation with lasers. Nobody knew, how beneficial lasers would be. Who knew that you can play music with lasers, right? So it's really important. So I focus on, a 10-week project, so that what the students come up with is a prototype that's functional, that benefits that individual. But I don't focus at all on commercialization, because number one, we're working with one person, and that a solution for that one person may not extrapolate into a solution for other people, because like I said, everybody is different. So going through this design process is really important. So here are some of my guest lectures. A lot of these people I work with are from people that work at the three other professors at Stanford, a PhD candidate that's doing brain-computer interface, an occupational therapist, and a design person, and a student who actually commercialized her student project way back when. Okay, so those are, so I model each class session after the Tonight Show with Johnny Carson. So I get up and I do my monologue, you know, for like 10 or 15 minutes, and then we have a little break, and then the guest lecturer comes on and talks about you know, these interesting topics. So yeah, so Peter here is a person who's a wheelchair user, and it turns out he was the first full-time student at Stanford who used a wheelchair. And so he's done some fantastic things in the area of disability, adaptive sports, and stuff. And so he goes through like 200 slides in an hour, and he's, because I have him every year, he became so proficient at doing this. So I bring back the same guest lectures because they get better every year. Although sometimes I have new people. And then I have people from the community who suggest projects, either for themselves or their clients. This is a group of people who wanted to somehow use robotics in dance. And but nobody took on that project. Lecture topics are meant to be interesting, things that students had never heard about before, like brain-computer interfaces, like exoskeletons, like prosthetics, like adaptive sports, like low-tech assistive technology, stuff like that. So it's all, I hope it's interesting to the students. So now I'll go through some of this project, and this is from about 3 weeks ago. This is at the last class session, where the students are given a table outside and set up their projects. And I go around with my course assistant and we evaluate the functionality of every device. And I'm eating a burrito here. I bring in burritos for everybody. So it's a very low-key trade show-like atmosphere. And the students get to see the other projects and get to ask questions, and we just have a lot of fun. And here's some of the things they worked on. So we work with the Magical Bridge Playground, and they're always looking for new additions to their park. The Magical Bridge Playground is a playground that was designed from the bottom up to be accessible and inclusive, and that resulted in a playground that is so totally different than, you know, an ADA compliant playground. So it's actually set a new standard by just, you know, wiping out what everybody else has done. So students are imagining, you know, other devices in there, including a device that they can open up and feel the textures, move things around. And this could be made really, you know, big and may provide shelter. At the bottom of to start off their project. Okay. So Sylvia is a wheelchair user who uses a catheter, and so the students wanted to make a custom bag for her that looked aesthetically good, and it was supposed to have artistic expression on it, and that didn't happen really well, and the students had a tough job sewing it, but it worked out fine. Sometimes they get more benefit from, you know, working with the person than actually coming up with their device. So here's a high-tech device. So this is for Danny, who has a service dog, and Danny is a person who's a wheelchair user. He has limited vision and grasp, and has cerebral palsy. And the service dog sleeps in this kennel at night, but he has a problem, you know, unlatching the door and opening it up so it doesn't interfere with his wheelchair. So that's a challenge that I identified. And so the students came up with a device that they hit this button. There's a computer in here that unlatches, that has a servo motor that unlatches the latch here, and a stepper motor that opens the door, and it just works perfectly. And it's also available by through Alexa, so we can command it by voice to open. So, I mean, there's no device like this on the market. There were a couple of similar devices, but they're off the market. And here's another solution for Danny. So everybody who uses a wheelchair has problems with storage, you know, where to put things. And so this team worked on a bag that fits on the side of the wheelchair that's easily accessible. And since Danny has a problem, you know, grabbing a zipper, they use this adaptive opening device so he can easily work it. This was an awesome lap tray that students made. Every person who uses a wheelchair needs to have a surface, you know, to put their stuff on, whether it's a laptop or, you know, food or laundry in this case. And this turned out to be really good. So that it's hard to see the details, but this lap tray splits in the middle and it sort of folds in on itself, and so it opens. It's able to be removed once you fold it up, and once you put it in, it has clamps along the side that clamp against the armrests. So it's a sort of a new design that I've never seen before, and it was made to be, you know, fit him exactly. So that was really good. So this is the other project for the Magical Bridge Playground, and the students went there and they saw the playground littered with cardboard, and so the kids use cardboard to go down the slide faster, or down the hill that the slide is on. And so they did that from day one. And so the students said, oh, there's got to be a better way of doing this. So they came up with a couple designs for the sleds, and here's me on there. And I'm telling you, you know, going down the slide when you're older is very scary, as you can see here. But that's that, and you know, I had to do it just to give students a laugh.
Slide sled.
Sorry?
The slide sled.
Slide sled. Okay, that's a good name for it. So a storage solution for Abby, who's a wheelchair user, and the issue there with her is that she has multiple wheelchairs, and so to make a storage system that only fits on one, you know, wouldn't be good. So they came up with a design with two pieces, and this piece folds into the slot here on the other side, and that is around the armrest. So that works for 3 wheelchairs and 2 scooters. So that was a good design, and they picked out some very colorful material and sewed it up. This is for Abby's service dog, Nathan, and anybody that has a dog that they train knows that when the dog does something good, you're supposed to give them a treat immediately. Well, for Abby, she has the treats in her backpack, on the back of the wheelchair, and she has issues with her hands, and it takes a while for her to get the treats out and provide it. So the students 3D printed this device, and all she has to do is rotate this knob, and treats will come out. And there's actually the clicker on it. So the clicker indicates to the dog that to expect a reward. So they start salivating and looking forward to a reward. So that worked out really good. And from last year, students made this sort of pinball machine for the playground. So if you have a service dog, the dog needs to be fed and hydrated. So this year we worked on the design for this system. So this is a reservoir, and when Danny presses the reservoir, water comes up into the bowl, and the dog on the first day knew that that was water for him to drink. So that was like a really easy solution. A lot of these solutions, can be, really simple. So, yeah. And they also came up with a holder for him so that, he has a hard time seeing and placing things. So they 3D printed this thing that would ease the iPhone into the cradle, and this is a holder for it for the iPhone. So that's a recharging station. This is another playground attraction, and the students are using this clay material that when wet, it produces a dark image. So that's could be something that students can use repetitively in the playground to draw things. But the use of water, you really don't have water in a playground, so that's sort of problematic. This is a team that worked on a dog leash system for Corey. Danny, again, has really trouble with his hands. He can't operate the buckle. And so the students came up with a magnetic attachment. So there's a bunch of magnets in here and on the leash and on the dog. So all the students have to do is all Danny has to do is put the leash onto this, and then attaches. And by sort of twisting it, it unattaches. So, and that was done by a team of students with no engineering background at all, but they were able to do it. So Mary is a student who has a prosthetic leg, and I always thought it'd be a neat idea to, dress up that prosthetic leg. I wanted to have the students work on something that would, light up as she walked or as she danced or to the music and stuff. But Mary just wanted something that, looks a little bit different. So here's something that is easily laced onto her prosthetic leg that she can, decorate in a fashion that she likes. So this is the lower leg of Kat and her dog. Okay, and Kat had this issue with nerve damage in her shin, and she liked to go to concerts, but the music caused pain. So the students were given the task, find something that would attenuate the sound so she wouldn't have pain. And sure enough, they found something, and it turned out to be acoustic insulator made for cars where you have the big, boombox speakers in it. So they bought this thing, for $15 and made it into a sleeve, and it worked great. So that was neat. Okay, who remembers this dog? Okay, it's from Up. And what was the dog's name? Doug, right. So remember the collar that Doug wore? What did it do?
It allowed him to speak English.
Yeah, so it was a brain-computer interface that allowed him to vocalize what he was thinking. So we did sort of the same thing in class, but it's not a brain-computer interface. So everybody that has a service dog has this problem where people see the dog and they say, oh, it's a dog, and this is something I need to get my dog fixed. I need to go up to the person and say, oh, what a cute dog. What's his name? How old is he? How much does he weigh? And of course, a service dog is working. And so you're disrupting the service dog's, work ethic. So, what the owner has to do is say, don't disturb the dog. He's working, don't distract him. And every time, she's out, you say it again and again and again. So what this thing does, this is just a Bluetooth speaker, and this is a bunch of switches with a Bluetooth interface. And when you press the button, it sends an MP3 over Bluetooth. And so you can have the dog say anything you want. You can say it in the owner's voice or a presumed dog's voice and stuff. So, so this actually was awarded second place in the student design competition this past year. So that was really, yeah. But, you have to identify these problems. So here's Abby again, and she has a special wheelchair, and she wanted a place to put her laptop because she goes out for coffee and wants to work on their Macintosh computer and have the mouse there and have it, the ability for it to break down so she can put it in her backpack. So those were the design criteria. So the students came up with this really nice piece of acrylic and some PVC piping that fits under her cushion on her wheelchair. And so it's very easy to use. And these guys that were on this team were all athletes, and that's what they came up with. So that was really neat. So in summary, the course is one that focuses on building confidence, enhancing professional skills. We go on a field trip to the Magical Bridge Playground. We have the lectures, we have the projects. I have an assistive technology fair where I bring in companies and services related to disability and assistive technology. And we sort of have a trade show atmosphere. And this was actually one thing that worked really good over Zoom on COVID, because I put each vendor in a different breakout room and the students just went from one breakout room to another. This year I was a little worried because we only had like 5 vendors, but that gave students a lot more time to spend at each table, and it worked out really, really well. Okay. Students also reflect on their experience. And so, again, assistive technology benefits everybody. Everybody benefits. We use assistive technology every day. Does that mean we're disabled? Well, I mean, we're not, a superhero like Superman would say, you guys can't even fly. You're that disabled, you can't even fly. But yeah. Okay, what else do we got here? I want to just go a little bit through this design process that we use in the class. And, so these are slides that I use. So the process is a step-by-step plan of action employed by the students to achieve their goal. And using it as a structured way increases the chances of success. And of course, students respond to getting good grades. So there's lots of design processes. And at Stanford, the D School has design thinking that has all these hexagons, which they promote as being a general design process that anybody can use in any context, but that it doesn't work in my class. And these are some other named processes, and it's at Northwestern. Their process is called whole brain engineering. So, I mean, that's different. So, there's lots of activities in the design process, and the one I want to focus on is the problem and challenge. So basically, what I do in the class is I search for these challenges and problems, I identify them, I describe them, I make up a description that's on the website, and that the students can review before the problems are pitched to the class on the second day of class. But the most important part of this, which I haven't seen enunciated in any of these design process, is to understand the problem, okay? I mean, it's just super obvious to me. The more you understand about the problem, the better the solution you'll come up with. And all these other design processes, I've never seen this mentioned, so it's really important. So you need to understand the problem to determine what is needed. So you need to have this knowledge that you can use to brainstorm ideas that would solve that. I mean, to me, it's just so obvious. And of course, you need to understand, incorporate what the user says. And so the students have to go in and interview the user, observe them, observe the challenge, talk to them and see, they even go to the community partners, home to see the challenge in context, okay? And of course, I encourage students to go on the internet, see what else is available,
David?
talk to experts.
David, in terms of observing,
Yes.
what do you think the trade-offs are in being the user? In other words, being not interviewing them, not observing them as an anthropologist, but actually modeling them, being, you know, acting, you know, taking on their persona.
No, we don't use personas in the class because personas are imaginary people, and I want to make sure that they talk to a real person that has a real challenge that can be enunciated and observed, you know, through observation and interviewed to get a sense of the person and what their goals are and things like that. And that's really important because, I mean, that's the customer. And in my course, you know, it's the only customer. They only work to solve the problem of that one person, because even though there's lots of people with the disability, to say, build something that will help, you know, 10,000 people with this disability, how are you going to, you know, get background from 10,000 people? And, you know, also considering that everybody with a disability is pretty much an individual. So to make things simple for the student, you know, we would work with that one individual. And I don't care about the commercialization part of it because I couldn't fit that into a 10-week course to begin with. And, you know, making a commercial product is something that may take years and millions of dollars. And I don't have the kind of funding for the class. And most of the time it's not going to be successful. So going through this process for one person is sufficient for the class. That's what I've come up with. So you have to understand the person. I don't like the term empathy because empathy is like this, knowing exactly how somebody feels. But what we want is to include the desire to address the problem. Okay, and that's called compassion. So the students have to find out as much as you can about the user's background, about the disability condition, and solicit, you know, information from family members, other healthcare professionals, and you know, talk to other people. And so here's a couple of slogans I've come up with to describe this process. The user will have a very good handle on what the problem is and what their challenges are, but he or she may not be a designer or an engineer, so they may not fully appreciate the benefits and limitations of technology. Okay, so there's two groups of people here. There's the students, and then there's the user, and then there's me. Okay, so everybody has a little bit different role in there. So since each person has their own circumstances, desire, and sense of aesthetics, the solution for one user may not be applicable for the entire population. Now, there's a slogan in assistive technology that says, solve for one and extend to many, but I don't think that works with people with disability because of these differences in each individual. So again, I'm not interested in commercialization at all.
Ask another question.
Yes.
You brought up that topic that you design for one person several times.
Yeah.
That is kind of in contrast, you might say, to the whole idea of universal design, which is make things that work for disability and will help everybody. And I can think of many examples of that. I've even made many examples of that. And you're not focusing on it because you just don't believe in it, or because you think it's a stronger point of view and more helpful to your designers?
Well, the issue here is universal design is a very important concept, but it's things that best work when there's a shared resource, when there's a building that needs to be accessible for everyone, where the internet has to be accessible because a lot of people with disabilities use it. But when you talk about a device for an individual, something that it's different. Universal design it's not required if it's something that just that one person uses. Okay, does that answer your problem or not?
I don't want to belabor it. I just want to point out that a lot of people use, well, when Apple made a really serious effort in the disability package. And I went to the, American Federation for the Blind.
Yeah.
They had this huge room full of assistive devices, and they said, all of these are worse than this iPhone now. And so I think it's very exciting when people make something that's a tool that many, many people can use. And I think it's possible. And so that's, that doesn't mean that your point that working for an individual isn't valuable. I just can think of places where universal design has been helpful.
Yeah, for a product, you want that because that one product is going to be a shared product for lots of people. But a lot of times it doesn't work that way, that an individual may, that may not help a specific individual or may have to be customized for that individual.
So just to blow my own horn, the track point
Yeah.
was useful in many, many different ways for people with disability that I hadn't anticipated.
Right.
And, I could go into that in detail, not here. But so that's kind of exciting when you make something that actually is flexible enough and powerful enough in its own ways that it gets used by many people.
Right.
That's all.
Okay, I'll agree with that. Okay. Oh, so part of understanding the problem is going through catalogs and reviewing other literature, and the questions that students should be asking is, are there products on the market already that sort of address this problem? And if there are, what are the most commonly used? Which one are commonly used? What is considered standard? And sometimes is, why aren't the products that are on the market solutions? Why do people still need something? So those are all questions to ask. So you build on existing solutions, but, and this is my top level slogan. So I used to say, sometimes the only problem is a lack of awareness of a suitable existing solution. But now I say most of the time. So if you're a person with a disability, you probably don't know what's out there because you're just one person and you're not on the internet. But occupational therapist or a rehab engineer might have a broader view. And when somebody approaches me with a challenge, the first thing I'll do is I'll go online and Google something. And most of the time, I get pages and pages of possible solutions. And to me, it's terrible to copy something that's already available. It's a waste of time and money. So I always make sure that these challenges will have a unique solution, that they aren't already addressed in their entirety. So some of the reasons why current solutions don't work: they may cost a lot of money, they may weigh a lot, they may be unreliable, ineffective. The users may not use them for one reason or another because it may be a poor aesthetics, or they don't function specifically for that individual. They again may not fit that individual, or it may not take care of current technology. But I had a person who we made a custom-made walking stick for, and it had, like, we took her a mold of her grip, and they 3D printed that, and we made got a custom cane and colored it, and it's nice. And she said, I have this cane that I made that has duct tape on it, and I actually like that better. So you can't tell. Sometimes people like what they're using better. Okay. Judge the need. So, a lot of times people talk about need finding, and to me, that's not the right term, because need is a judgment in my mind. Okay. And so you only can judge what's needed by having a full knowledge of the problem, a full understanding of the problem. Okay. You can't start brainstorming until you have this knowledge. Okay. And this is what the D School thinks of as brainstorming, using a lot of Post-it notes. So there's all sorts of techniques for doing brainstorming. So the idea is to come up with lots of ideas, and I tell people to think of wild ideas, and they're not done until they cross over to the other side of the laws of physics and stuff like that, and talk about, you know, really weird things, because at that point, you know, your mind is open to new kinds of ideas. Don't get stuck on the original idea. I had a student who all she wanted to do was brainstorm. So every new person she met was another opportunity for brainstorming. And she filled up like 2 sketchbooks, you know, brainstorming ideas. You just got to move past that. If you're in a process, you have to go through the process and you can't get stuck. And there may be technology out there that you can apply to your the current problem. So this is Henry Evans, and he's using this laser pointer to point to an alphabet board because he's a non-vocal individual. So that worked out really great. Other people use the Google Glass because they're a photographer with a disability. So there's all sorts of things that are on the market that could be adapted for people with disability. Students, you know, obviously need to talk to the person that they're working with and observe the problem and challenge. Encourage them to tell the story about what they do, how they live, about how they do things. And so the understanding that they should have from that is to understand what a solution should do, but maybe it's too early to say how it should work. And an underrated design feature is coolness. Everybody, you know, wants to look cool, even people with disabilities and older adults. So when you come up with lots of ideas, you put it in a pew chart, a spreadsheet, and one of the factors, besides all the design concepts, is coolness. So it has to be cool. That has to be checked off. Okay. And students need to interact with that person with every prototype they make, so they get feedback and suggestions so they can refine their design. So the design process does not include building to somebody else's blueprint or making incremental improvements on things. Students who work in a class, you know, they have resources from the course resource people. In the product realization lab, there's 24 graduate students who can assist them. Their classmates can help them. And of course, I help them as well. But the students have to make and justify all their own project decisions. You know, why did you do that? So to summarize, assistive technology is a highly fragmented market. A small market means that there's high prices for the products, and the companies are small. And so if they're working on a bunch of prototypes, and I tell them, you know, your first prototypes are going to fail, or they're not going to work, you should anticipate that. You should start out working with low resolution materials, making something quick to get an idea, because once you need to have it in 3D form, because that's how your brain works in 3D. You can turn things over and point to things and stuff. So that's what I encourage.
Before you move off that slide, I just had a question.
Yeah.
So first of all, the best part of the presentation for me was the student projects.
Yeah.
I really appreciated that.
Yeah.
So thank you for shepherding the young minds to achieve what they did, because I'm sure that had an impact. But on a previous slide, you say a small market means high prices. And then on the other hand, you say that up to 1 in 4 individuals in the US have disabilities.
Right.
So I go to this conference every few years. I can't make it every year.
What's it called?
At CSUN.
Yes,
Northridge.
I was at the first 25 of them.
Exactly. So it is the place to go and learn about assistive technology and accessibility. And I talked to an inventor over there. I had run into him accidentally. And he told me, you know, I'm really frustrated because the assistive technology is really amazing, but the people who have disabilities are usually underemployed. They cannot afford it. The prices are too high. So what are the solutions? Number one, you could say, okay, government assistance, fine. You know, we need a safety net. Let's do that. Second thing is maybe technology gets cheaper. Third thing, actually like what you had said, which is universal design. Maybe the fact that Apple, gave a toss and put accessibility in from the get-go
Right.
into the device helps everybody, including people with disabilities. And because it was such a mass-produced product, it helped everybody, diffusion of
Right.
innovation, right?
Right.
So what is your answer to this
Right.
challenge where you have people who cannot afford it, yet they need it? How do
Oh.
you cross that?
Right. I think that the solution is outside of engineering, perhaps. So you talked about,
It's economics, yeah.
yeah, it's economics. So in the VA, they have a policy where they'll provide anything that a veteran with a disability needs, including $100,000 prosthetic arm and probably exoskeletons. And they'll modify a van for a wheelchair user. The user buys the van and the VA will pay for any modifications. So that's sort of the top end of insurance. But places like, Medicare, they are at the other end of the spectrum as far as provision of this. In fact, they'll only provide one wheelchair for a person and it's only an indoor wheelchair. They think a person with a disability is not going to be working and doesn't need, and so there's a long-term issue there. Did you give me a speed up? Okay. So the final thing is just going through some devices and products that are out there, and maybe I'll go through these pretty quickly. So this is a device I did in early '80s probably, and it's for people like this who are quadriplegic. And so she's using a tilt and space wheelchair, a power wheelchair that had a joystick on it. Well, she can't use the joystick. So what do? So I developed a system in this box here that has an 8-bit Z80 processor in it and connected it up to a couple Polaroid ultrasonic sensors that monitor the head position. So it will sense, how far you've tilted your head and in what direction. So I use that as control inputs. And so your head has become the top of the joystick, and it's wireless. You wear nothing. And so this is a long time ago. I have a little bit of a video here, but I'm not sure it's going to play and probably don't have time. But you can see how old this is. What? Do you want to? Can you set it?
I can help you out.
Okay, thanks. I really appreciate it.
Hopefully it doesn't pin.
Use the.
Oh.
Oh, there we go. No, that's not it.
For goodness sake. I'll just play this
There,
one.
yeah, there it is. Here, just hit that. Hit play. Yeah, so this is me. Notice my head tilting, and so you can see how old this video is, because this was before I started dyeing my hair gray, right? Okay, everybody see that? Did that get out there? Okay, well,
Yes, it did play.
okay.
Just had no sound.
The video is not playing through the Zoom link, through the Zoom video meeting.
Oh, okay, let's move on. Okay, so this is a robotic hand that does finger spelling, which is a subset of sign language that represents letters, and everybody knows that this is V for victory, and there's other letters. So when somebody is doing sign language, when they come to a word for which there's no two-handed gesture, they spell it out. So what I've created here was a hand that has a bunch of servos in it that moves each finger in response to key presses on a keyboard. So it basically moves each finger appropriately. But we'll move on from that. I worked on a driving simulator, and the idea here is to assess the driving abilities of people post-stroke without having them actually driving in a car, and possibly training them to drive better after stroke. So this is a commercial device. This is a bunch of buttons that can be programmed for a specific action on the computer, moving the cursor, opening a program, and things like that. So these are on the market. This is another thing on the market. This is a Glidance glide system. So this is a device that that a person who's blind can use to seek out the free produced. There's many versions of this that have been done over the years. So this is like nothing new, but it's a new product, but this is just a reincarnation of a long line of existing products that do the same thing, including robot guide dogs, things like that. Okay, this is the Voltrex Type and Talk. Who remembers this? Okay, this is 1981. I had one of these, and this had a serial port, and you just said to it, and it would speak it. So that was really neat. But another version called the Tech Talk. Who knows about this? This was even better because it had various voices in it, and it had telephone connection. And so with this system, I actually made a dial-up website, audio website. You can dial in, and using the touch have a sport called Beep Baseball. Did this to communicate to people in Rochester, New York, the surrounding areas, and where to go for dinner and stuff like that. So
this comes around again because it's 1984, and now we have text to speech, speech to text, and text to video AI technologies.
Yeah.
Right, which people are paying like. I just got a purchase order, at work for like $300,000 for this very thing, which was already done in 1984.
yeah,
Right, where somebody wants to give it a PowerPoint or a script, and then it'll create an avatar that'll talk and deliver, some training or give a marketing pitch.
Yeah.
Yet this was already there in 1984.
right.
So funny.
Yeah. This had 8 different persons' voices, men and women, and a child, and you can all program that through escape sequences, and it would speak anything that you sent to it.
Well, the one today will actually do it in 18 languages.
Okay.
In real time.
Well,
So the technology does go forward, but
Right.
With
yes,
a lot of affect and
yeah.
That's
a lot of cool things.
yeah,
But
yeah.
This thing is filled with EEPROMs where the program was, because they didn't have very dense chips in those days. So there must be about 20 large EEPROMs in there that held the program. And so for screen reading software, there exists this JAWS. So it's has the ability of navigating the screen for blind people, but it's very expensive. I think it's like $700 for this one program. Yeah. Speech recognition. There's Dragon Dictate and Dragon Natural Speaking, and apparently, what's his name? Reese, and it's used a lot in commercially for dictating reports and doctors' reports, things like that. And a lot of people who don't have the mobility to type, use it. Brain-computer interfaces. This is a student of mine, and using a neuroscape keyboard that would scan through the first row of letters, second row and third row, and you just blinked when the letter that you desire is lit up, and then it would scan a subset of that row, and all by blinks. And this is would be helpful for a person who is a quadriplegic.
And such a product existed in 1983 also.
Right. Yeah. This was a little bit later, and now they sell a version for like $50. And of course, we've all seen brain-computer interfaces. This is a woman that has a couple cables coming out of her brain that has sensors, and she can control. At this time, it was one robotic arm just by thought, and I think she progressed to controlling 2 robotic arms at the same time, which is actually pretty amazing. And of course, we have the Neuralink device, which has 1,000 electrodes. And, here's a guy that's playing, video games using it. So this is the state of the art. This is what Neuralink is doing these days. So that's it. I hope I haven't gone over time or got you too bored or whatever. But if you have any.
Yeah, well, I want to start with Al. I had a question online. Can you unmute and speak for yourself, or I will speak your question myself?
I can just come over there and yell.
No, I just wanted to ask it if you want to.
I guess I can.
Go ahead.
Are you able to hear me?
Yeah,
Yes.
we can hear you.
Okay, great. Great talk. Thank you so much for sharing all this. This is it's really good. So my question is, from your perspective, as robotics evolve and they become highly intelligent and mobile, which seem to be coming up relatively soon, maybe not in our lifetime, but relatively soon. Do you think?
Or maybe.
Yeah, well,
Go ahead.
Robotics helping disabled in all kinds of different ways, on
Are you okay? You got it, Al?
on their behalf. Do you
Finish your
think?
question, or I can read it for you.
Yeah. Do you think that's going to introduce new issues, or it's going to be a lifesaver for many people?
That's
Excuse me, we can't hear anything.
okay. Okay. You should be able to hear me now.
Yeah. After my question, it completely went quiet. So maybe you'd like to re-answer it. I'm sorry about that.
Well, I think technology will advance, and there will be applications that would be more workable for people with disabilities. But there may have to be specialized robots for certain things. There may be, a robot for cooking, another one for, toileting or getting food and stuff like that. So maybe multiple robots specifically designed for specific applications might be the answer.
I think part of the question that I saw online was
Okay.
the issue of when we start having AI answering with ChatGPT and stuff like that. When it takes over for a person, do they lose agency? And when does it cause problems and when does it solve problems?
Right. It depends on what the robot is meant to do. If it's meant to be a caregiving robot and assist the person, then maybe there's no issue. But it's another thing to have it speak for that individual or act for that individual. So that's something completely different.
So at this point, I don't know if some people that haven't asked questions, I've been asking a few, want to ask something, or it's getting a little late, and you know, maybe that'll be close to the end. But does any of you guys want to maybe add to the commentary at all, please? No? Okay. Oh, Larry. I mean, Pete.
Pitlin here from Other Lab. Just wondering a little bit about neurodiversity and with in very specific ways.
Yeah, I can't hear him though.
Oh, sorry.
What diversity he's asking
Okay, I'll just use my voice.
Yeah.
I'm wondering a little bit about neurodiversity and whether or not, obviously, different people have different things they're strong at, other things they're weak at, and whether or not we will be able to directly compensate these things.
Right.
In
Yeah, this is a big issue. I mean, I've always thought that everybody has something to contribute, even if it's a person with Down syndrome or somebody with autism. Everybody has something to contribute. So making that contribution happen through assistive technology or robots or brain-computer interfaces is something to look forward to.
Ted Tucker again. Yeah, I actually think that even when you take a very small population, even when you think you are, you know, selecting for certain kinds of people, it turns out the full diversity of problems and creatives and people that are good at doing, you know, in rote work come out of the in the population. And I think maybe it's because these different abilities that people have are useful in different situations. And actually that diversity is kind of what makes us more viable.
Right. I know that there are vocational training programs specifically for people with autism. And so, you know, everybody can be a contributor. I've seen some awful great artwork and music produced by people with disabilities. Great writing. There's a number of students at Stanford with disabilities, and they all write for the Stanford Daily, and they're just awesome. So I see potential and contribution in everybody.
So with that, Dave, so you've been very broad discussion. You've given us an understanding of disabilities in general, and also what you teach in your classes, but more importantly, a lot of different examples across a large spectrum. Really, more mechanically oriented, not so much software in your examples. So my last question is, and then we'll probably have to call it a night very, very soon.
Yeah.
What do you think of the possibility of your class taking on more software projects? And what do you think the reasons that it might be more fun to stay with a mechanical or move over to?
Right. I have had software projects in the past, but I really enjoy when people create something physical. Okay. But I'm not adverse to software, but I like devices a lot. I like, you know, the hands-on buildings of things.
But you can imagine a course that is it's all about AI and interaction.
Well,
not that you're not your class, not your class. Obviously.
Yeah. I do have a small AI component in the course. When students are trying to understand the problem, I ask them to ask AI about what kinds of solutions AI might have, and I have the students comment on those responses. And so there was 3 teams that went through that exercise. But before we go, I want to just give my email address. It's Dave Jaffe at stanford.edu. And the course website is engr110.stanford.edu. And if anybody's around campus during the winter quarter, they're welcome to sit in on the class.
Great. I want to just close by saying thank you. I really want to look forward to more people coming these in-person things, and in fact, the most important thing about that is that tonight you would have gotten cake, pizza, and maybe even some wine. So I really a dozen or more people that have come, and I'm trying to grow the online presence. It's kind of hard to climb out of, but thank you again for coming, and we'll see you again next month on Tuesday evening.
And thank you, Ted, for inviting me.
You're welcome. It's
Yeah.
my pleasure.
Thanks. I got